So welcome to this lesson on Fourier transforms. This is the last part of my series on Fourier transforms, and here you will learn how to evaluate the Fourier sine and cosine transforms, which we have already seen before. In addition to this, you will also learn differentiation under the integral sign. This is a formula in integration. So find the Fourier sine transform of e raised to minus ax by x where a greater than 0. The Fourier sine transform is given by FSU is integral 0 to infinity fx sine ux dx. That is integral 0 to infinity e raised to minus ax by x sine ux dx. Now this is the differentiation under the integral sign formula, which says that d dt of integral a to b f of xt dx becomes integral a to b partial derivative with respect to t of f of xt dx. So here d du of fsu will be integral 0 to infinity partial e raised to minus ax by x partial derivative with respect to u of sine ux dx, because otherwise integrating this becomes difficult. There are three functions. So this becomes e raised to minus ax by x cos ux into x, because you're differentiating with respect to u. So the x and x gets cancelled and it is integral 0 to infinity e raised to minus ax cos ux dx. Now we have the formula integral e raised to x cos bx dx is e raised to ax by a squared plus b squared a cos bx plus b sin bx. So using this formula, d du of fsu becomes e raised to minus ax by a squared plus u squared minus a cos ux plus u sin ux within the limits x equal to 0 to infinity. So that will be e raised to minus infinity is 1 by infinity, which is 0. So 0 minus, this becomes e raised to 0 when I put x as 0, 1 by a squared plus u squared minus a, because sine 0 is 0. So this is a by u, a squared plus u squared. So we have seen that d du of fsu will be a by a squared plus u squared. So what will be FSU? It will be integral of this. That will be integral of this with respect to u. It is 1 by a. It's a into 1 by a tan inverse u by a plus c. So this is just tan inverse u by a plus c. Now if u equal to 0, FSU. What is FSU? FSU is basically e raised to minus ax by a. So when u is 0, FSU becomes just C, because Fs0 is 0. Fs0, I'm coming back to this, Fs0 will be e raised to 0. FSU will be integral 0 to infinity. This becomes 0. So FSU becomes 0 and so C is 0. So FSU will be tan inverse u by a. Fs at the point 0 is 0. So this is your answer. Coming to the next question, for the function fx, where the Fourier cosine transform is f alpha equal to a minus alpha by 2, where alpha lies between 0 and 2a, equal to 0 when alpha greater than 2a, find fx. So we again use the fact that Fourier cosine transform of u, if it is integral 0 to infinity fx ux dx, then fx becomes 2 by pi integral 0 to infinity f of cu cos ux dx. This is the inverse Fourier cosine transform, as we had seen in the earlier class. So your fx becomes here 2 by pi integral 0 to infinity. It becomes a fx f of alpha. fcu will be f of alpha here. Fourier cosine transform is this, f of alpha cos alpha x dx. You are replacing u by alpha. So this is 2 by pi integral 0 to 2a, a minus alpha by 2 cos alpha x dx, and it is 0 because alpha greater than 2a. So this is 2 by pi integrating by parts. The order is right, algebraic and trigonometric. So a minus alpha by 2 sin alpha x by alpha within the limit 0 to 2a minus integral 0 to 2a. Derivative of this will be minus half sin alpha x by alpha d alpha within the limit 0 to 2a. So that will be 2 by pi, when you put alpha as 2a, you get 1 by a 2a minus alpha by 2. That will be, so this whole thing becomes 0 because you get a minus a and sine 0 is 0. So this is plus 1 by 2 alpha integral 0 to 2a sine alpha x dx. That will be 1 by 2 gets cancelled, 1 by pi alpha. Integral of sine alpha x is minus cos alpha x by alpha within the limit 0 to 2a. That is 1 by pi alpha minus cos 2 alpha a by alpha minus plus. You'll get 0, cos 0 is 1, 1 by alpha. So your fx becomes 1 by pi alpha squared, 1 minus cos 2a alpha, taking alpha out. Coming to the next question, find the Fourier sine and cosine transform of 2 e raised to minus 3x plus 3 e raised to minus 2x. So fs of fx will be integral 0 to infinity fx sine ux dx. That will be the Fourier sine transform, integral 0 to infinity 2 e raised to minus 3x sine ux dx plus 3 times integral 0 to infinity e raised to minus 2x sine ux dx. Now we have the formula integral e raised to ax sine bx dx is e raised to ax by a squared plus b squared, a sine bx minus b cos bx. So the Fourier sine series becomes 2 e raised to minus 3x by 9 plus u squared minus 3 sine ux minus u cos ux within the limits s equal to 0 to infinity. So x equal to 0 to infinity plus 3 times again the same thing e raised to minus 2x by 4 plus u squared minus 2 sine to ux minus u cos ux again within the limits x equal to 0 to infinity. You're integrating with respect to x. So when you do that, you get it as 2, this whole thing becomes 0 and this becomes minus, this thing sine u is 0. So you will get plus u cos u is 1 by 9 plus u squared. Again the same thing here. This whole thing becomes 0. When you substitute infinity anyway, you get 1 by infinity is 0. And you get you get plus u by 4 plus u squared when I put u as x as 0. So that will be u into 2, take out the u, 2 by 9 plus u squared plus 3 by 4 plus u squared. Similarly, the Fourier cosine series is twice integral 0 to infinity e raised to minus 3x cos ux dx plus 3 times integral 0 to infinity e raised to minus 2x cos ux dx. I'm again going to the definition of fx. And again we use this formula integral e raised to ax cos bx dx. We use these formulas a lot in Fourier transforms. So this is e raised to ax by a squared plus b squared, a cos bx plus b sin bx. This is the formula. So your Fourier cosine series will be 2 e raised to minus 3x, this is a cosine series, by 9 plus u squared minus 3 cos ux plus u sin ux plus 3 e raised to minus 3x by 4 minus 2x by 4 plus u squared minus 2 cos ux plus u sin ux within the limits x equal to 0 to infinity. So substituting, when you put infinity, this becomes 0. When you put x equal to 0, you get it as minus 3 by 9 plus u squared. So minus will give you plus. Again here you get plus 3. Infinity will give you 0. Then you get minus of minus. So 2 by 4 plus u squared. So that will be 6 into 1 by 9 plus u squared plus, take out 3. Can take out 6, 1 by 9 plus u squared by 1 plus 4 plus u squared. So this is basically the Fourier cosine series. So that comes to the end of this class, and we have seen more problems on how to evaluate Fourier sine and cosine transforms, and also a lot of integration. We have also seen one application of differentiation under the integral sign. Thank you.